Now for our second example of finding domains and ranges of functions using graphs, we have this nice parabolic shaped graph here. First question that we need to ask always, before we can find domain and range, is whether or not this is indeed a function. The question you always need to ask yourself with this is, does each x value I plug in give me only one y value? If the answer to that question is yes, then you have a function. If there is an x value that you can get two y values out for, such as in the S-curve that I demonstrated in the last video, check that out if you didn't see it, then you do not have a function. Plug in one x value, if you can't tell which y value comes out, then it is not a function. In this case, we have a function because every single x value I plug in gives me exactly one height. Okay? So we have a function. What's the domain? Domain, as always, is the set of all possible x values that I can plug into this guy and get a corresponding y value. All right? Remember, the arrows mean that the graph is just going to keep going on forever in that general trajectory. So this is just going to keep going and going and going forever. If I could keep drawing and shift the camera, I would, but my camera's kind of fixed right now. So going, and same thing in the negative direction. So if this arrow means I'm just going to keep going out to infinity, heading up forever. Okay, so the domain, what can I plug in and get a y value out for? Can I plug in 2 and get a y value? Absolutely. Can I plug in 2.1 and get a y value? Yeah. Can I plug in 2.00001, something really close to 2, and get a y value out? Absolutely. Can I plug in really large values, such as 4 billion? Like if I went really far out here, could I get a y value out? The answer is yes, because this graph continues forever. All right? So in this case, the domain of this graph, or this function, is going to be everything, because I can plug in any negative number and get a y value out. I can plug in any positive number that I think of and get a y value out. I can plug in 0 as well. So my domain is everything, negative infinity to infinity. There's no stopping. Okay? Range is the set of all possible y values that come out of my function. So here's how I like to do this, and I tend to do the same thing for domain as well. But here's what we do. We start scanning from minus infinity with a horizontal line, and we see where the graph starts. So scan up, then start yet, then start yet, then start yet, boop, okay, at y is equal to 0, I started. Where do I stop? I keep scanning, I'm touching the graph, touching the graph, touching the graph, keep going. I will still touch the graph even up here because the arrows tell me I keep going. So do I ever stop? The answer is no. So I started at y is equal to 0, and I go up to forever, basically. So I start at 0, so I use a square bracket because I do touch y is equal to 0. It starts at it, there's no hole here. So y is equal to 0, and then goes to infinity. We always put round brackets on infinity because infinity is not a number that can be plugged in. All this indicates is that we can plug in numbers as large as we like, or we'll get out numbers as large as we like, depending on domain or range. So scanning, just scanning up, started at 0, continue on. That's what the range is. All right, so we have domain, we have range, we know that this is a function, so we're in good shape. So yeah, if you found this helpful, please like and subscribe. If you want to see yet more examples of this, please head over to projectgradered.com if you're not watching from there already. The link's in the description. See you in the next video.